So in this video, let's look at how to convert an extensive form game into a normal form game. So let's consider a simple extensive form game. So let's say we have two players in the game. So player one gets to play the game first, and player one has, let's say, 3 strategies to play the game at the initial node. So let's say they are A, B, and O. And the payoff here is 0 to player 1, 4 to player 2. And if player 1 moves, A or P, then player 2 gets to play the game, but player 2 doesn't know what player 1 had chosen, A or P. So in that case, player 2 has 2 strategies to play the game, X or Y. So the payoffs are 3 and 3, 4 and 2, 2 and 4, and here 2 and 2. So this is the game we have. So how do we convert this game, extensive form game, into a normal form game? So first, let's write down the strategy spaces. So for player 1, the strategy is A, B, and O. And for player 2, the strategy set consists of X and Y. All right, so we can draw a 3x2 game here. So the matrix, the normal form, will have 3 rows and 2 columns. 3 rows are for 3 strategies of player 1 and 2 columns for player 2. So I can do it here. So we have 3 rows and 2 columns. So player 1, player 2. So X and Y are the strategies for player 2, and A, B, and O are the strategies for player 1. So if player 1 plays A and player 2 chooses X, then the payoff is 3 to player 1 and 3 to player 2, right? So we can write that down here. And if player 1, it's highlighted. So if player 1 chooses A and player 2 chooses Y, so like this, then the payoffs are 4 and 2. And if player 1 chooses P, so going like this, and player 2 chooses X, then the payoffs are 2 and 4. And if player 2 chooses Y instead of X, then the payoffs are 2 and 2. And if player 1 chooses O here, then player 2 doesn't get to play the game. So in that case, payoffs are 0 and 4, 0 and 4. So this is how you represent an extensive form game into a normal form game. Let's consider another game, extensive form game, just to make sure that you understand this concept well. So let's take another game. So here, there are 3 stages to the game. So player 1 moves at the initial node, and player 1 has 2 strategies: move down or move forward. And then player 2 gets to play the game. And the second stage, player 2 can move down as well, or move forward. And then player one gets to play the game again in the third stage of the game, where it can move down D prime or move forward. Either way, the game ends. So let's say the payoffs are 2 to player 1, 2 to player 2. And over here, 1 to player 1 and 3 to player 2. And over here, 3 to player 1 and 4 to player 2. And over here, 4 to player 1 and 2 to player 2. So let's write down the strategy set for player 1. So here, player 1's strategy set consists of D. So in the first stage, player 1 can move down, but then you also have to tell, player 1 has to specify what C is going to do if C reaches the third stage of the game, right? So keep in mind that strategy requires you to specify actions in every possible contingency, right? So if player 1 moves down, game ends, we know that. But even then, the player 1 has to tell what he's going to do at the third stage over here, right? At this node. So let's say player 1 says he's going to move forward, right? So that's one strategy. Another strategy would be move down and at the third stage. And player 1, if she moves forward, then she has to specify what she's going to do at the third stage, even if it doesn't reach, and then F and D prime. So these are the 4 strategies for player 1 in this game. And for player 2, there are only 2 strategies, move down or forward. So D and F. All right, so that's how you write the strategy sets for both players here. Next, we can convert this game into a normal form game. So the matrix will have 4 by 2 dimension, 4 rows and 2 columns. The rows are for player 1 and columns are for player 2. So we have 4 rows here, so player 1 and 2. So player 2 has 2 strategies, D and F, and player 1 has 4 strategies, D, F prime, D, D prime, F, F prime, and F, D prime. So next, so let's fill in the payoffs here. So if player 1 moves down in the first stage, right, over here, game ends. It doesn't matter what player 1 says he's going to do at the third stage and what player 2 does in the second stage. It's immaterial, right? So the payoffs are going to be 2 and 2, right? So if player moves down, game ends, right, with the payoffs of 2 and 2. It doesn't matter what they do at what they say they're going to do. All right, at other nodes. And similarly here, D, D prime, same case, right? Player 1 moves down, game ends. So payoffs are going to be 2 and 2. But if player moves forward instead, right, F, then player 2 gets to play the game, can move forward or down, right? And depending on then, player 1 can be in play in the third stage. So if player 1 moves forward and player 2 chooses to move down, then game ends with a payoff of 1 and 3. So player 1 doesn't get to play the game again in the third stage. And if player 2 moves forward, then this F prime is relevant, right? So move forward, player 2 moves forward, and then player 1 gets to move forward, then the payoff is going to be 4 and 2. And here, F, player 1 moves forward, F, like this, and then player 2 moves down, game ends, so 1, 3. And if player moves forward, player 2 moves forward as well, and then player 1 moves down, D prime, then the payoffs are 3 and 4. So this is your normal form representation of the extensive form game here.